Okay, so welcome to learning intention number 9, aim number 9, lesson number 9, however you want to call it. Okay, so it says how many quarters, nickels, and pennies are needed to make $1.13. So basically we have different answers for that. Okay, so one of the answers could be I don't know, 4 quarters. I guess 4 quarters make $1, right? So 4 quarters. You could write 4 quarters. I'm not gonna write 4 quarters. Okay, 4 quarters. 2 nickels. How do you spell nickels? Oh. I'm not gonna put the dog in the video.
Why?
Because no. I'm gonna stop being on the video because every time I'm on the video he comes and bites the cables and all that stuff. No. And 3 pennies. Yep, that's $1.13. Nice, right? Okay. So B, it says fill in the blanks. So 8,943 is equal to, well, 8 times 1,000 is 8,000. 900. 4 times 10 is 40. And then 3 times 1 is 3. So that. Okay. Now what else? Oh wow. Now it's in exponent form, in exponential form. Okay, no problem. 8 times 10 to the 3 is 10 times 10 times 10, which is 1,000. So it should be 8 times 1,000. 10 to the second is 100, so still 9, 10, and then 3. Wow, that was difficult, right? Sure. Okay, let's go to C. What do I have for C? The same number, but now I have 20 to the third power. 20 to the third power is 20 times 20 times 20. Okay, so what is 20 to the third power? Let me see. 20 to the third power. That's 8,000. Okay. Wait, no. 20 to the third power is 8,000. So this number should be 1. 1 times 8,000 is 8,000. Then 20 to the second power is 400. So I would need 2, yeah. 2 times 400 is 800. And then here times 20. Okay, do me a favor. You need to pause this and figure this out yourselves. Seven times 20 is 140, and then 3 times 1. Okay, but you need to figure out on your own. This is like 4th grade stuff, so I don't want to be doing it for you. Okay, fill in the blanks. 113 should be what? What number goes here? Oh my god. Oh wow, thank you. What number goes here? And what number goes here? Beautiful, beautiful, beautiful. Okay, exercise number 2. Let me see if I can zoom out and hopefully everybody can see it at the same time. Oh gosh, let me see. Okay, so I don't want to make it smaller because then it's gonna be like, cannot see, Mr. Becker. All right, now let's be as general as possible by not identifying which base we are in. Just call it base x. Okay, so we have an expression. This is what we call a polynomial. Okay, it's basically an expression that involves variables, exponents, okay, and regular numbers. So we have the expression x to the third power plus 2 times x to the second power plus 7 times x, which you could say 7x. Plus 3 times 1, or equivalently x to the third, okay, plus 2x squared, okay, plus 7x, which is 7 times x, plus 3, which is 3 times 1. Okay, what is the value of this expression if x is 10? Well, if x is 10, if I was to rewrite the whole expression, I would write x to the third power. If x is 10, it will be 10 to the third power, plus 2 times x to the second power, that would be 10 to the second power, okay, plus 7 times x, so just x, okay, plus 3 times 1, which is 3. Okay, now we put that in the calculator and we get, what do we get? That, right? But you have to do it yourself first. Don't wait for me to do it, okay? I'm just trying to help you here. I'm just trying to, like, once you do it, you compare your answer to mine and then you see, oh wow, I messed up or I got the wrong answer. All right. So it says, what would happen if x is equal to 20? Okay, so you follow the same process. So I'm gonna give you time to answer the question. So you have x to the third power, 2x squared. So you will have 2 times x squared. Okay. And then 7x. And then 7x plus 3. Alright. So what is that equal to? Come on, use the calculators. Okay, very good. 8,943. Okay, now what does it say on D? It says when writing numbers in base 10, we only allow coefficients of 0 through 9. Why is that? I don't know. When writing numbers in base 10, we only allow coefficients of 0 through 9. Why is that? Well, once you get 10 of a given unit, okay, once you get 10 of a given unit, right? Once you get 10 of the given unit, you also have 1 of the unit to the left of that. So you also have 1 of, oops, sorry, let me see. 1 of, you also have 1 of the given unit to the left of that. As simple as that. Okay, let's answer the next question then. Okay, good. So what is the value of 22x plus 3 when x is 5? How much money is 22 nickels and 3 pennies? Hello? You gotta do that one. So you have 22x, but what is x? X is 5. Okay, and then plus 3. Now 5. Wait, hold on a second. 5 can be represented as nickels. Okay, cool then. So when you multiply that, you get 113, which is equivalent to $1.13. Okay, $1.13. Let's go to C. Okay, what number is represented by 4x squared plus 17x? Oh my god, who texted me? Oh, okay, that's Miss Sweeney. Okay, What number is represented by 4x squared plus 17x plus 2 if x is 10? Oh, please. Remember what x is. So this is 4 times x squared. So 4 times 10 squared plus 17x. 17 times x, which x is 10. So it's 17 times 10 plus 2. And that equals to... Cool then. Alright, so we got that one. Okay, let's go to D then. What number is represented by 4x squared plus 17x plus 2 if x is negative 2? Or if x is 2/3. So that means that we have to do both. So remember, 4x squared means 4 times x squared. What is the value of x? Negative 2. So 4 times negative 2 squared plus 17 times negative 2 plus 2. So that is the first scenario. So what do I get? Right, we get negative 16. All you have to do is put it on the calculator and you'll get it. Now, why am I showing you this one when I was supposed to show you this one? So once again, I'm going to have to repeat it. So what number is represented by 4x squared plus 17x plus 2 if x is negative 2? So we get this negative 2 in lieu of x. Instead of x, we write negative 2. So 4 times x squared will be negative 2 squared plus 17 times x, in this case 17 times negative 2 plus 2, that's negative 16. Now let's try when x is negative, when x is 2/3. So we get 4 times 2/3, okay, squared plus 17 times 2/3 plus 2. Alright, so I'm gonna actually go the extra step and I'm gonna say, okay, 4 times 2/3 squared. 4 times, what is 2/3 to the second power? Well, when you raise a fraction to whatever exponent, you're raising the whole thing. So that's 4/9, because 2 squared is 4 and 3 squared is 9, plus 17 times 2/3. When you multiply by a fraction, when you multiply a whole number by a fraction, it's nice if you want to put the 1 under the number, or if not, just remember that this you multiply by the numerator and you get divided by the denominator. So 17 times 2. What is 17 times 2? Let me see. Oh my God, come on, my math skills. 34. So 17 times 2 is 34 over 3. If you put a 1 under the 17 times 2 is 34, and 1 times 3 is 3, so that's how you get it. And then plus 2. Now, 4 times 4 over 9, that's going to give you 16 over 9. And then the rest is 34 over 3 plus 2. If you want to put it over 1, that's fine. And now, remember something. You need to find a common denominator. In this case, where does 9, 3, and 1 meet on the times table? At 9, right? So my common denominator is going to be 9. Now you gotta turn this into equivalent fractions. How do I turn this into a 9? Multiply by 3 over 3. How do I turn this into a 9? Multiply by 9 over 9. And then once you have them equal in denominator, you add the numerators and subtract the denominators. And that's what you're gonna get, but you have to show more work than I did. What number is represented by negative 3x squared plus radical 2? And look, the x, I don't think the x is included here. That's why when I do it, I like to close in the whole radical thing. Okay. So when x is radical 2. So how do I do it? Well, let's see. Negative 3 times radical 2 squared plus radical 2 times x, which is radical 2, plus 1/2. All right. So let's see what this says. When you have, remember that squaring a number is the inverse of taking the square root. So when you apply both like that, then they're gonna cancel each other. So this is gonna cancel with the square root. So basically what you have here is negative 3 times 2. I hope you understand that. Squaring a number and taking the square root are inverses. One is the inverse of the other. So you have to, they cancel out. So if you have the square root of 2 to the second power, they cancel out. Therefore, only the number gets liberated right here. It gets freed. So I'm free. 2 is free. So that's why you have negative 3 times 2. Plus, now when you are multiplying radical 2 times radical 2, when you multiply a square root times itself, is the same thing as squaring it, right? So this is the same thing as saying radical 2 to the second power. Or if you want to, you could say that radical 2 times radical 2 is radical 4. Although it's more advisable to say that radical 2 times radical 2 is radical 2 to the second power, so they can cancel each other. So what you have, negative 6. This radical 4 is 2. Negative 6 plus 2 is negative 4. Negative 4 plus 0.5, okay, negative 4, so you have negative 4 plus 1/2. So then, this is negative 4 over 1. In order to add them, we need to have the same denominator, so we need this 1 to become a 2. So we have to multiply by 2. So we multiply by 2 over 2. So we end up with negative 8 over 2, right? When you multiply it by 2 over 2, plus 1 over 2. And then we end up with negative 7 over 2. And that's it. And that's your answer. Oh, okay. Let's move on then. Oh, okay. So a polynomial expression is either a numerical expression or a variable symbol, or the result of placing two previously generated polynomial expressions into the blank of the addition operator, plus, or the multiplication operator, plus. Kobe, no, Kobito. Go over there. Váyase por allá. Lo voy. Ay, Kobe, ten tu juguete. Alright, so just a little technical support. Just, the dog is kind of like acting out, and it's it's about this time where he gets activated, and then I have to like grow gray hair. It don't matter. Oh wait, hold on a second. I caught you again. Alright, so find each sum or difference by combining the parts that are alike. So this is your job. Take your time, do it. If you did it before I did, then congratulations. Remember to give you extra points. If you didn't, then too bad. All right, so we're gonna start. Remember that when you add polynomials or subtract polynomials, you gotta add the like terms. Okay. So what is this equal to? Well, let's see. 4x squared plus 2x squared is 6x squared. Good. So look, what I do is I'm gonna cancel them out to know that I worked them out already. X goes with 1. No, goes with 3x. So 1x, it doesn't have to have the 1. How many x's do you see? 1. Duh. So then that's 1x. So 1 plus 3x is 4x. And then 7 is a loose number, just a regular number. And 1 is also a loose number, regular number. So 7 plus 1, 8. Got it? Okay then, so let's work the other problems out. Yeah, I can make this larger. Okay, let's do it. Three x to the third minus x to the third is 2x to the third. Negative x squared minus 5x squared. What is negative x squared? Negative 1. Look, they're like terms, so you don't have to worry about the x and the exponent. We have to worry about the coefficient. So this is negative 1 minus positive 5. Look, negative 1. Where can I write it? We have negative 1 minus positive 5. In other words, we have negative 1. Remember that what I said? Just multiply the symbols together and you get one sign. So we get negative 1 minus 5. Go to negative 1 and then move 5 units to the left and you get what? Negative 6, right? So this is negative 6x squared. Now we have 8 minus, we got x to the third, we got x squared. 4x goes with nothing. 4x goes with nothing. But remember something. You have a subtraction sign here. And subtraction is also distributive. Remember how I read it. Remember how we read it. Negative 1 minus 5. Negative 1 minus 5. But then again, we have a 4x, but we have a minus sign here. So the minus multiplies the 4x. So negative times positive is negative. So we have minus 4x, right? And then we have 8 minus negative 7. 8 minus negative 7. That's what we have. Okay, 8 minus negative 7. Look, 8 minus negative 7. What happens? What have I told you when you have two signs together? To multiply them. Negative times negative is positive. So therefore, in other words, you have 8 plus 7. Get it? Please tell me you get it. So 8 minus 7 is the same thing as 8 plus 7 because you multiply these two signs together. So we got 8 plus 7 is 15. So we get it. All right. Kobe, leave me alone. All right. So the next one. In the next one, we have to actually apply the distributive property first, and then we could like mess around with it. So let's utilize the distributive property here. So 3 times x to the third is 3x to the third plus 8. No. 3 times 8 is 24. Oh my God, I'm making me say the same mistake. So I multiply by everything? Yes. Now, negative 2 times x to the third is minus 2x to the third. Negative 2 times 12 is negative 24. Now we're talking. Now let's add the like terms. Where are the like terms? Here and here. So what is 3x squared minus 2x? Sorry. What is 3x to the third minus 2x to the third? That's 1x to the third. Kobe, don't eat the phone. No. Kobe. Jesus. Oh my God. You wanna be on camera, Kobe? Cause you're killing me. So now what I'm gonna do is I'm gonna cancel this out. Kobe. Okay. And then let me see. 24x doesn't go with anything. You see 24, negative 24. Do not even think about combining them. This has an x, this doesn't, so you cannot. Please try to understand that. So I'm just gonna write plus 24x and then minus 24x. Gucci? Okay. Let us move on. Okay, here this is an addition, not a multiplication. So first, do I have like terms here? No. Do I have like terms here? No. So that means that I gotta combine this parenthesis with this parenthesis. So let's see, 5. I'm gonna write down 5 because I don't see any other regular number here. Now negative t is gonna go with 9t. So what is negative 1t plus 9t? Well, negative 1 plus 9 is 8. Negative 1t plus 9t is the same thing as saying 9t minus 1t is 8t. Now we're going with negative t squared. Negative t squared plus positive t squared. Nothing. Remember the additive inverses. Look, positive t squared, negative t squared, and you're adding, so they cancel each other out. Got it? Okay. And let's do this one now. Now you are going to do it on your own. I'm just gonna help you in a little while. So you see, the negative, since you have a negative, this is like saying negative 1 times p plus 2. So negative 1 times p is negative p. Negative 1 times 2 is negative 2. I hope you do understand this part. If not, then I'm going to have to explain to you until you understand it. All right. So now, do we have like terms? Yeah, we have 3p and positive 6p. That's 9p. So look, just in case, because I don't want to recount them again. 1, positive 1, right? 1 minus 48 is negative 47 minus p minus 2. Guess what? I'm not going to say I made a mistake because I'm the master here. But really, I still have like terms with the p. I forgot about this. So I'm going to correct my mistake right here. 9p minus 1p is 8p. So boom, boom. And negative 47 minus 2 is negative 49. Boom. Got it, right? Okay. So now, let us move on. Oh gosh, I gotta make this smaller so we can actually see what it says. Me muero. Okay, so Selena says that each of the following expressions is actually a binomial in disguise. So I'm assuming that's what they want us to prove. Alright, so that's not a problem. So we got each of this. So what am I supposed to do? For example, she sees that the expression in the first one is algebraically equivalent to 11 ABC. Okay. Oh, okay. She's happy to write this as 11 ABC plus negative 2a squared if you prefer. Is she right about the remaining 4 expressions? Well, let's see. So how was she able to express? Okay, So negative 5abc minus 2a squared plus 6abc. So what I'm gonna do is I am going to actually, okay, so you read the whole thing, and now I have to make sure that everybody understands this. Okay, right here. So let's see, binomials. Sure. 5abc plus 6abc is 11abc, and then you have minus 2a squared. Now we usually write terms starting with the largest exponent, so this would be actually negative 2a squared plus 11abc, and that's basically what she said. So your job now is you're going to simplify each of these expressions and see if they end up as binomials. So good luck. So let's see now. This is the product rule. So 5x squared, 5x to the third times 2x squared is 10x to the fifth, right? So this is, let me see now. This is 10x to the fifth, right? Minus 10x to the fourth plus 3 times x to the fifth times, plus 3x times negative 2, That's easy. All right, so what I'm gonna do is I'm gonna get some extra paper because I don't have extra paper at all, and I don't want to be doing all this, or maybe I can. If I have space, I will do it. So let's see now. Minus 10x to the fourth then, oh my god, then 3x to the fifth, okay, plus 3x to the fifth, and then plus 3x times negative 2x to the fourth, that is minus 6x to the fifth. Okay, and now we have the like term, so 10x to the fifth, 3x to the fifth, and negative 6x to the fifth. So the whole thing can be as 10 plus 3 is 13, 13 minus 6 is 7, so this is the same thing as 7x to the fifth, okay, 7x to the fifth minus 10x to the fourth, minus 10x to the fourth. And yes, this is a binomial again. Okay, now try this one. T plus 2 and the whole thing squared minus 4t. You already know what t plus 2 to the second power should be, right? T plus 2 times t plus 2. And now you multiplied each and everything, right? So you get t times t is t squared, so t squared plus 2t, because you multiply by everything, right? Now 2 times t is 2t, and then 2 times 2 is 4. And then of course the one that we forgot is minus 4t, because we forgot. So then again, 2t, okay, t squared, we're gonna have t squared, right? And then plus what, 2, 4, oh wow, 2t plus 2t is 4t, minus 4t is 0, so we just get plus 4. Okay, I get it. And this is what we got. All right, I'm not gonna do any more for you because this is not that's not the point. We still got a long way to go. So what I'm gonna do is you guys are going to work on the rest of the problems. Just make sure that you could see them. And anyway, you have a handout, so that shouldn't be a problem. Let me go and look for a charger for the camera, which I should have somewhere in here, because the camera is going to die. And if it dies, we cannot do anything about it. So continue working with the problems while I untangle this thing and hope that the dog will not eat it. And where is this thing right here? Okay. So we Gucci. Okay, we continue with the recording. Now this is crazy. So where was I? Okay. Remember, and I'm just gonna guide you, okay? You gotta use the distributive property here. 5 times a is 5a. So you better write that down over here. Then 5 times -1 is -5. Right? So you have 5a minus 5. And now we gotta use the distributive property over here. -10 times a is -10a. And then -10 times -1 is +10. Negative times negative is positive. Plus 100 times a minus 1. Okay, 100. Positive 100 times a is positive 100a. Then we have positive 100 times -1 is -100. And now, my friends, you're going to add the like terms. I'm not going to help you with that. Let me help you with the next problem. So we have 2 pi r minus pi r squared times r. Guess what? It doesn't matter where this is. Look, you had -10 parentheses, so you have to multiply. Well, here you have parentheses and then you have the number or the letter. Guess what? This still implies multiplication. It doesn't matter whether the r is here or at the end of the parentheses. You're still gonna have to multiply. So then let's do it. So pi times r. Let me see if I can find. Okay, you know what? I'm gonna give you, take like a minute or so to work on this problem. Remember, you gotta use the distributive property. So you're gonna have to multiply r times 2 pi r squared. 2 pi r, and then r times pi r squared. Then guess what? This is also distributive property because it's parentheses multiplied by 2r. So it doesn't matter where the 2r is. The 2r could have been over here, and you still have to distribute it. So you're gonna multiply 2r times this and 2r times this. So take your time, multiply. I'll be back in a second, okay? Okay, so I'm back. I took a break and I'm back. So let's see if we understand. I am going to write it in a separate piece. Let me see. You cannot see them. Okay, that's what you have, right? So r times 2 pi r squared. Well, remember something, that the r is not going to multiply the 2, is not going to multiply the pi. The r is going to multiply the r. So we have 2 pi r to the second power. Positive times negative, negative. So r times pi r squared is going to be pi r to the what power? Exactly. Finally, you're getting it. Now, we're going to do the following. We're going to switch this to pi r. I'm sorry, this 2r. We're going to switch it over here. Because we still have this. You know what? Forget it. I'm just going to write minus. And then 2r times 2 pi r. Well, I have a 2, so it has got to go with the 2, right? So it has to be 4. Pi is not being multiplied by anything, so it's pi. R times r is r squared. And now, remember, this is kind of difficult to explain. I should have explained it before, but it's okay. I wanted to put this 2r over here to make it minus 2r. Why is that? Because if I was to put the 2r over here, then it would have been negative 2r times negative this, which will give you a positive. Because if I do it right now, you're gonna call me crazy, but I'm gonna have to put parentheses around it. Okay? And now 2r times negative pi r squared is negative 2 pi r squared. Okay, and that's what you get. Now we need to remove parentheses, so I am going to write a little smaller. So I have 2 pi r squared minus pi r to the third minus 4 pi r squared, and then look, plus 2 pi r squared. Now I'm gonna have to combine like terms. So I have this with pi r squared with pi r squared. So let's see now. 2 pi r squared plus 2 pi r squared is 4 pi r squared. 4 pi r squared minus 4 pi r squared is 0. We got issues here. Something did not come out right. Okay. Minus 4 pi r squared. Okay, something is not right. Okay, so you know what? Easy. If it's not right, I'm gonna have to rewrite the expression. I'm gonna rewrite the expression. 2 pi r minus pi r squared, okay, times r. But this time I'm gonna put the r over here. Minus 2r, I'm putting the 2r in front of the parentheses, minus 2r times 2 pi r minus pi r squared. Okay, that's basically what I have. Let me see if you can see this. So that's what I have, right? Okay. Okay, so now let us multiply. Let us multiply. R times 2 pi, okay, I forgot the r over here. Then pi r squared minus 2 pi r squared 2r. Okay, let's see where my mistake was, because if I made a mistake, I made a mistake. I'm not perfect. So r times 2r squared, okay, so this is 2 pi, okay, 2 pi r squared minus pi r to the third, okay, minus 4 pi r squared plus 2 pi r to the third. Beautiful. I see what my mistake is. I forgot about this. Okay, now let's combine like terms. So pi r squared with pi r squared. So that is negative 2 pi r squared. Negative pi r to the third with 2 pi r to the third. Negative 1 plus 2 is 1, so plus pi r to the third. Okay, that was the mistake. If you still don't understand this problem, don't worry, I can always explain to you. Okay, this was a long example. This is not my idea of adding polynomials, but good too. All right, so Janie, now let's go with Janie. What does Janie want? So Janie writes a polynomial expression using only one variable, right? X with degree 3. Max writes a polynomial expression using only one variable, x, with degree 7, exponent 7, exponente 7. What can you determine about the degree of the sum of Jane's and Max's polynomials? Uh-oh. Who's writing to me? Oh, somebody. Okay. Let's see now. Oh, sorry guys. What can you determine about the degree of the difference of Janie's and Max's polynomial? Oh, come on. I thought it was something like very difficult. Alright. So basically what I can determine is the maximum degree could be 5. The degree of the sum of Janie's and Max's polynomials. Remember something. Janie writes a polynomial expression using only one variable, x, with degree 3. Then Max also writes a polynomial expression using only one variable, x, with degree 7. Now, if we start adding the polynomials, right, what can you determine about the degree of the sum of Janie's and Max's polynomial? Okay, so let me write it down. Oh, no. What am I doing? His degree is 7. Oh, no. So the maximum degree, it could be 7. Right? Oh, my God. How could I be wrong? Okay. B. What can you determine about the degree of the difference of Janie's and Max's polynomials? For B, okay, so I'm sorry, this is not part of the answer. The answer is just the maximum degree could be 7. And guess what? What can you determine about the degree of the difference? If they subtract them, the degree would be what? Well, if you have x to the 7 minus something, you have to have x to the 7. So the degree would still be 7. I don't know what I was babbling about. Anyways. Alright, so let's see now. Okay, number 3. So it says, boom. Oh, okay. So suppose that Jenny writes a polynomial expression using only one variable x with degree of 5. And Max writes a polynomial expression using only one variable with degree 5. Okay. What can you determine about the degree sum and Jenny? Please. We know that the maximum is going to be degree 5, so that's what you write. And what can you determine about the difference? Well, that the difference could also be a degree 5 or maybe anything less than degree 5, but definitely degree 5, so that's what you're writing here. Alright, so let's see now. Time for you to get to work on this. Let me see now. Oh, okay. Remember, you have to show your work. You have to attempt each of these problems. Don't just copy the answer because you're not going to learn. And when you get the test, you're going to fail it. You have to show work. I'm just doing this out of comparison. We already learned how to add them. Here you have to use the distributive property. Remember that. So you have to show work. If you need to use a separate paper, then that's fine. Okay, let's see now. Finally, we're done with that one. If you have any questions, please, you could text me, okay, send me a comment, or just, if you're my student, just ask me personally, like what's going on, and I'll really explain to you what happened, okay? So, I'll see you on the next episode of How Do We Pass Our Common Core Algebra class, subject / regions. All right. Bye-bye. Got you.